Hey guys, welcome back. These are the worked out solutions to the practice exam. Um, you can basically pause the video and take your time doing it. But the first problem was the integral of x to the fourth plus the cube root of x. First thing you guys want to do is you want to make sure that the cube root of x is written as x to the 1/3 power. You can remind yourself how exponents are by numerators are the guys on the inside, denominators are on the guys outside. All you have to do is add 1 to the exponent, so 4 plus 1 is 5, and then divide by 5. You have to add 1 to a third, you get 4/3, and then when you divide, you get 3/4 in the front. Don't forget your plus c. For the next part, we have to integrate quotients, but we know we can't integrate quotients. So the first thing I'm going to do is I'm going to rewrite 5 over x as 5 times 1 over x. You don't have to do that part, but I did it so you guys can see that the integral of 5 over x is the same thing as 5 natural log of x. Then I realized that the square root of x is x to the 1/2, but because it's in the denominator, I have to bring it up and put a negative there. So what we're going to do is we're going to add 1 to the negative 1/2. You're going to get a positive 1/2, and then when you divide by a positive 1/2, that means multiply by 2. When you clean it up, you say 2 times 3 is 6, and then x to the 1/2, you can leave it as 6x to the 1/2, but we know that x to the 1/2 means square root. So this is your answer. Once again, if I'm going too quick, pause the video and take a look at the worked out solution. The next problem that I gave was a problem that had a division sign. Once again, you cannot integrate quotients, so what you're going to do is you're going to take a look at the denominator, and because it's a monomial, you're going to split it up. X to the fourth over x to the third, x squared over x to the third. So x to the fourth over x to the third is x to the first, because when the bases are the same, you subtract the exponents. Similarly, there's 2 on top, 3 on the bottom, which means there's going to be 1 left. When you go to integrate this, all you have to do is add 1 to the exponent and divide, and the natural log of x is the integral of 1 over x. So again, pause the video and take your time, but this is your solution. For the next one, we're going to have to, so our problem, the next problem is 1 over 9 plus x squared minus 1 over the square root of 4 minus x squared. What you notice is that it is a quotient, so you can't integrate it, but the exponents differ by 2. You should try to think of arctan when it doesn't have a square root and arcsine when it does. The way that this works is 1 over 1 plus x squared is arctan x. Okay, generally speaking, 1 over a squared plus u squared is arctan. You take the square root of this person here, okay? That's an a, and you go 1 over a, and you take the square root of this person here, and that's your u. So it's going to be 1 over a arctan u over a, and then don't forget that 1 over u prime in the beginning. Similarly, for arcsine, it's going to be 1 over the square root of a squared minus u squared. So it's going to be arcsine u over a, and then 1 over u prime. The difference between arctan and arcsine is that there's no u prime. So how do we do this problem here in red? Well, I'm going to identify this a as 3 and the u as x. So I'm just going to use this formula. I'm going to go 1 over a arctan u over a. Since the derivative of u is just 1, I don't need to put 1 over 1. Similarly, I'm going to identify 2 as my a and x as my u. But there is no 1 over a in the front, so you get arcsine x over 2. And so the blue is your final answer. Okay, again, pause the video. I left this blank here because these are basic definitions or basic integrals. The integral of tan x minus cotan x. I did this in our last video. These are the 4. You should absolutely know them. The integral of tan x is negative natural log cosine x. The integral of cotangent x is positive natural log sine x. So this final answer is just negative ln cosine x minus from here, but it's a positive ln sine x plus c. Okay? So those are just straight, I hate saying formulas, but straight integrals, okay? The next one, it's a product, okay? You can't integrate products. What you want to do is you want to make sure for trigonometric functions, most likely that your angle is going to be your u. So we have x to the fifth as our u. We're going to set that equal to u. We're going to take the derivative, and then after we take the derivative, we're going to solve for dx. We're going to rewrite it in order. 5x to the fourth, secant u, du over 5x, because that's what dx is. Now, once these cancel out, you're left with secant u. What's the integral of secant u? Secant u is a special. Secant u is natural log of secant x plus tan x plus c. So that's what I have here, and then all I have to do is put back the x to the fifth for the u's, and then you're finished. For the next one, it's a product, but the most important thing for these types of problems is that everyone should see that the exponents inside the base is 1, well, this is 1, so they're both identical. When they don't differ by 1 and you do a u substitution, you're going to have to solve for one of them in terms of the others. So for example, I'm going to make my base u equal x plus 3, my du dx to equal to 1, so du equals dx. When I go back in order, I leave this x here, I have u to the 7th, and then I have dx to be du. I can't have x and u, so what I do is, I said since u is equal to x plus 3, from up here, I'm going to just solve for x to be u minus 3. The reason why that's important is because now this is to the first power, which allows you to distribute. So that's going to be u to the 8th, that's going to be negative 3u to the 7th, and all I have to do now to integrate is just add 1 and divide, add 1 and divide, and then go back and substitute your u. Okay? So, for the next one, I actually made a mistake when I created the problem. I was trying to create a problem very similar to the one that's on my exam, and I basically swapped the problem. So on your paper, you'll see a square root of x plus 5 over x, but you should switch it. Okay, because once again, these match, what you want to do is you want to create the u equal x plus 5, because that's the person that has the exponent, right? It's the base part that I always talk about. And I actually said, I know since they match, I'm just going to solve for x right away. So x equals u minus 5. Du dx equals 1. You can try it up here. That gives you that. So let's go back in order. So x is really u minus 5. X plus 5 is really u, because square root means a half. Once again, because we have a monomial in the denominator, you could divide each piece separately. Did you know that 1 minus a half makes a half? And did you know that 5 over u to the half means bring me up as a negative? The rest is a piece of cake. All you have to do is add 1 to 1/2, you get 3 over 2, then you divide. And then the same thing here, you add 1/2 to negative a half, you get a positive half, and then you divide. And then you just clean up and you resubstitute your u. Okay, so anytime they're to the first power, remind yourself to do this little change of variable. Okay, this is very important. This is e to a exponent that's not 1, so that's going to be your u. You have to remind yourself that this is e, not to the x power, but e to the first, which means this is just a number. This is approximately 2.718. So it's just a number, and the derivative of a number is 0. So remember to do base angle exponents as your u. U is 2x plus e, therefore the derivative of 2x is 2. The derivative of e, which is a constant, 0. So you get this as your du over 2. So you go back in order and you put the e to the u du over 2. I'm going to pull out the 1/2, and I have the integral of e to the u. And when you integrate that, it's just going to be e to the u. And then your final answer will be 1/2 e to the 2x plus e. Just remind yourself that e to the first is just a number. E squared is just a number. If it was e to the x, then we have a different story. If it was e to the x, then you're going to have to pretty much break it up, right? So that wouldn't be possible at this, well, it wouldn't be possible there, but leave it alone, I guess. Okay, the next one, I gave you bounds on your paper. I gave you pi over 4 and I gave you 0. And so I'm going to integrate. You can pause the video. U equals 2x, du dx equals 2, du over 2 equals dx. You go back in order. Cosine u, du over 2. You pull out the 1/2, okay? The integral of cosine, who gives me cosine? Sine u, but you put back the u to be 2x. Now, this is the part you have to plug in the pi over 4 and the 0 and know your special angles. 2 pi over 4 reduces to pi over 2. Pi over 2 is 90 degrees. It's like our second finger. Sine of 90 is 1. Sine of 2 times 0 is 0. So 1 minus 0 is 1 times the half on the outside. Your final answer is 1/2. This is a quotient. You can't do quotients. Make the bottom u, the derivative of 3 plus x is just 1. Du equals dx. 1 over u, who gives me 1 over u? ln of u. I didn't put a plus c because, again, on my paper, I put bounds. So now just plug in the 5. You're going to get an 8. Plug in -2. You're going to get a 1. Just know that the natural log of 1 is actually 0. So that's why your final answer is the natural log of 8. The natural log of 1 is 0. The natural log of e is 1. So now we're on to the curves, okay? So you want to find the area between these two curves. First thing that you should do is probably graph it. If you don't want to graph it, just try to figure out who's on top of the other one. So I have to solve for it. You can solve for it graphically by saying that's 0 and 1, or you can set them equal to each other. If x squared is equal to the square root of x, you get rid of the square root by squaring both sides. So now you have x to the 4th equals x. You have to minus the x. You factor out an x, you get x to the 3rd minus 1. Who gives you 0 for x? 0 and 1. Those are your bounds. Top minus bottom. You can pause the video, and I just did this quickly, but basically 1 plus 1/2 is 3/2, 2/3. 1 plus 2 is 3 divided by 3. Plug in the 1, you get 2/3 minus 1/3. And then plug in 0, you get 0 minus 0. So 2/3 minus 1/3 is 1/3. Okay, and for the second part, you can pause the video. It's the same exact thing. You're going to take this and set it equal to this. We know that if you're going to set these quadratics over, I added x squared to both sides and I minused 4. So I have this, and it's a perfect, it factors out perfectly. X minus 3x plus 2. Put the 3, the -2. Top minus bottom. Because the parabola is negative, it's going to be upside down, so it's most likely going to be on top of the line. So I did this here. I subtracted. Remind yourself that that's a positive x, positive 2. So you get this here, and then you can pause. There's a lot of work here. To be honest, I'm too exhausted to do 27/2 minus a minus 22/3, which makes it a plus 22/3, but that's your final answer, whatever that is. Here's your work for it. You can pause the video. Okay, the second to last problem, or 2 problems left. This one says, here's f of x. What is f prime of x? When you are taking derivatives of integrals, all you have to do is plug in the variable bound into each piece, okay? And then at the very end, take the derivative of it. You might say, what about the 2? The 2 is a constant, so you don't need to plug it in. Once again, part B to that says, what's f prime of x? You're going to plug in x to the 3rd into every place that you see a t. So I plug that in, and I plug that in, and then I have to take the derivative of x to the 3rd, so that's 3x squared. You should clean this up to be x to the 9th. Okay, the next part is the area. The area from 1 to 7 is 20, the area from 1 to 4 is 7, and the area from 5 to 7 is 10. So what I like to do is I like to take every single one of these bounds and make it on a number line. 1, 4, 5, 7. Then I say, okay, 1 to 7 is 20, that's the pink. 1 to 4 is 7, that's that one. 5 to 7 is 10, that's that one. Well, what's missing here? Just 3, because 7 plus 3 plus 10 makes the 20. Just be very careful. If these are swapped, okay, if these are swapped, then it's equal to the negative answer, okay? Great. And here is our final question. I'm so sorry, I made another error. I had x plus 1 on your paper, I have to do x plus 2. So you set them equal to each other, you solve for their intersection, and then in this problem, you're only going to have to set it up. You want to revolve it around the line y equals 2. Y equals 2 is here. So you want to do longest distance squared minus shortest distance. So 2 minus x squared, squared, longest distance squared minus shortest distance squared. Okay? So that's how you do these problems. Email me if you have any